Hi everyone, Mr. Boltri here, bringing you video 3.1, where we're going to talk about energy basics. So to do that, first we're going to define energy, talk about the types of energy, and then introduce the concept of conservation of energy. So first, what is energy? This is probably a word that you've heard used in your everyday life. For example, if you say in the morning, like, oh man, I have no energy. Or if you eat a lot of candy or sugar, you're like, wow, I have so much energy. And that's because energy is one of the ways that we can measure energy is in calories. So food gives our body energy. And that's the same kind of energy that we're going to be talking about in physics class. It's just energy looks a little bit different in our bodies than it does in other physical situations because our bodies are pretty complicated. And we're going to try to simplify that down a little bit in this class and talk about some situations in which there is energy. But your natural intuition on what energy is, low energy versus high energy, is more or less correct. Just we're going to apply it to specifically some physical situations. So to do that, I want to show you 3 quick videos about some situations in which energy is acting. And I want you to think, where's the energy coming from? What's the energy doing? And then where's the energy going? So a little bit more simple than a human body. And let's watch another one. And so again, these are just some simplifications of examples of where there are energy. There are so many examples. I could do 100 of these, but I've just chosen 3 so you can see a couple different looks on what energy looks like. So in all 3 of those, except for the beginning of my career as a hand model, what do these situations have in common? So hopefully you'll notice that they're all pretty different. There's a car that has a spring inside. There's a little elastic popper thing. There's a hand crank flashlight, and they're all different. But the thing that they all have in common is they all use energy. So energy is this kind of broad term that can do a whole bunch of things. It can cause cars to zoom across the tables. It can cause things to fly up in the air. It can cause deformation. It can cause light. It can cause sound. Energy is this really broad term that can do a whole bunch of different things. So the definition that we're going to give it is going to be pretty broad because it has to encompass all of the different things that energy can do. And energy also can make you really hyperactive and want to run around and stuff. So from food. So energy is defined as, it's a measurement, it's a quantity that we can measure. We can sort of, we can't hold it or touch it like a force. You can feel a force. It's sort of hard to feel an energy, and you definitely can't hold it in your hand. It's not a physical thing, but it is a measurement, something we can measure, of the capability to produce a change. And so, for example, in the previous examples, it could be a change in position or change in velocity, change in shape, change in sound, change in heat. So energy, there's a lot of different things that it changes in height, a lot of different things that it can change. But broadly, it's the measurement of the capability to produce a change. And while in our common everyday lives, we might know energy because if we look at the back of a food package, we can see how many calories. In physics, we're going to be using the International Scientific Unit, which is a joule, which we're going to talk more about when we sort of dive deep into sort of quantifying energy. But this is just the overview video, so we're not going to get that deep into what is a joule. You'll just know that if you ever see joules or J, then that is a unit for energy. So now let's talk about different types of energy. And you'll notice that I have types in quotation marks because while it's an easy abbreviation for what's actually going on, it's not actually reflective of what's actually going on. So for example, when we say types of energy, it would be like saying types of money. So if I offered you $100 in cash versus $100 in Venmo, hopefully you would take it either way because $100 is $100. It doesn't matter so much how the money is stored or transferred. And so we could get down into the nitty gritty of maybe it matters for tax purposes and stuff. And the same is true of energy, is we really need to account for every little thing that's going on. But generally, you wouldn't turn your nose up at $100 in Venmo versus $100 in cash because it's just money and it doesn't really matter so much how it's stored or transferred. Well, energy is the same way. And so instead of saying types of energy, we might say mechanisms of energy storage and transfer. So like for money, you can store it in your bank account, you can store it in your backyard, you could transfer it using cash, you could transfer it using Venmo, and energy is the same way. So we might say types of energy, but I just want you to know that we're not talking about two distinct things. The energy is one monolithic thing. Energy is energy, period. So when we talk about types of energy, we're really just talking about ways that energy might be stored or transferred. So that out of the way, I will probably revert to sometimes just say, what type of energy is it? But we know that energy is one monolithic thing that we can look at in different ways. So here are some different ways that we can look at it. There's gravitational potential energy, and the symbol for potential energy is a U. And I'm not really sure why that is. It's something I need to look up, but it's a U for potential energy, and the subscript of G for gravitational, subscript of S for spring potential. So we have some potential energy. We have kinetic energy, which is the energy of something that is moving. We have work, which we're going to talk about later in this unit, which is energy transfer. And then we have dissipated energy, which usually falls under the category of work, but it's just energy that is spread out to the surroundings, usually in the form of heat and light, and is therefore not recoverable to our system. So once it's dissipated, we can't really get it back. So now that we sort of have a basic baseline fundamentals of what is energy, let's talk about the really important and interesting thing involving energy. And that is the idea that energy is conserved. So if you've never heard that word before, let me explain what it means. So conservation means that it is neither created nor destroyed. You've probably heard that before. But the important thing about conservation is it can move around. It can shift from one energy storage or one type of energy to another, or it can move into and out of systems. So this is really useful because it allows us to keep track of all of the energy in the whole universe. Energy is not being created or destroyed anywhere in the universe, so we can keep track of how much there is at any one given point. So to do that, we have to choose our system. We have to be very clear. Are we looking at the planet Earth? Are we looking at the solar system? Are we looking at the universe? Are we looking at this water bottle and the energy in the water bottle? Because it's going to be important for us to keep track of where we're looking specifically for the energy. So if it is a closed system, and that just means that energy is not going in or out, and sometimes we have to sort of wave our hands a little bit and idealize a closed system and sort of neglect some negligible energy. But if it's a closed system, then that means the energy at the beginning has to equal the energy at the end, because no energy is entering or leaving, and no energy is being created or destroyed. So if we have kinetic energy at the end, it might stay kinetic energy at the beginning and end, or it might transfer from one storage mechanism to another. The kinetic energy might turn into gravitational potential energy. But if we have 10 joules over here, then we need 10 joules over here if we have a closed system. And so we're going to do some examples with closed systems just because those are easier before we move on to open systems where energy can enter or leave. So then no longer is the initial energy going to equal the final energy if energy enters or leaves. So then we have to add a little term of the energy at the beginning plus or minus any energy that is added or taken away is going to have to equal the energy final. So this is a really important concept to understand, because it hinges on the idea that energy is not created or destroyed. So we can account for all of the energy by looking at how much there was at the beginning, how much enters or leaves, and then we can figure out how much there is at the end. And this is going to allow us to calculate some pretty complicated problems that forces would not have allowed us to calculate, because it's a little bit more of a robust idea, because because energy is so broad and it encapsulates a whole bunch of different types of changes, then we can keep track of a whole bunch of different things that are going on and see how they're all related to each other via the idea of energy. So this has just been the very basics of energy. We're going to do a whole unit on it, but I wanted to make sure that we were establishing some really good fundamentals, a really good foundation for our understanding of energy. So if you have any questions, please make sure to write them down, and I'm looking forward to diving back into some practice problems with you in our next class. But for now, this is Mr. Boltri wrapping up video 3.1 on energy basics, and go Bears.